In this video, we are going to discuss graphs. Before we start with the computer stuff, here is a neural network in a brain. Many points of activity are linked together. Here is another exercise in making weird shapes out of anything. Two things common with the images were that A. The individual points were connected by some link, and B. All the points that were connected were significant in some way, be it the response centers in the brain or the stars in the night sky. We have all enjoyed the puzzle Connect the Dots when we were young. In it, we used to join consecutive vertex numbers to form a beautiful picture. That is nothing but a graph. Moving on to the technical definition. Graph is an ordered pair of a set of v vertices and e edges. It is an abstract data type that is meant to implement the undirected graph and directed graph concepts from mathematics. A graph contains two components, vertices or places to which you want to holiday, and edges that are the roads that you will take to visit those places. To put simply, edges connect vertices. The distance between those two places becomes a weight or a cost of the road. Let's suppose that a person wants to go for a walk. He doesn't go anywhere in particular but returns back home. He has traveled some distance but he has returned to the same point. This is called a self loop in a graph, that is, an edge connecting the same vertex. A graph can be directed or undirected, weighted or unweighted. Directed graph shows source and destination vertices of any edge. Undirected graph does not give the direction of flow. A weighted graph shows costs required to connect two vertices using an edge, and unweighted graph doesn't have any representation of cost required to connect two vertices. Graph is represented by using two ways, adjacency matrix and adjacency list. Adjacency matrix is a two-dimensional matrix in which the rows represent source vertices and columns represent destination vertices. Adjacency list is another way of representing a graph. An array of linked list containing vertices is used. Each vertex is first element of its linked list, with all the vertices linked to it its subsequent elements. Let us consider a chessboard. Each move of a square of a particular piece can be viewed by using an adjacency matrix or an adjacency list. All possible moves which can be made by the knight are shown in the adjacency matrix. The same moves are also represented by an adjacency list. Adjacency matrix is an easy way to describe a graph. This is better for visual representation. Adjacency list is a compact representation of a graph, especially true for a sparse graph. Adjacency matrices use a large amount of space. Adjacency lists use less space, but finding the presence or absence of an edge is slower when using an adjacency list. That is, the space complexity is better when using an adjacency list, while adjacency matrix will give faster results when searching edges. We see examples of graphs everywhere. Computer networks are almost exclusively dependent on graphs. Every time you connect your PC to a Wi-Fi, it forms a graph. Your Facebook connections, your LinkedIn connections are all parts of multiple graphs. Highways, constellation of stars, the Avengers are all examples of graphs. We will cover important topics related to graphs in the upcoming videos.